review problem number 9. Let's go. Which of the following groups of isoelectronic species, not sure what that means, are we, show the elements arranged correctly in order of increasing size? So we've got to put these things in order. So I have taken the liberty to draw a little mini periodic table here. And we've got oxygen, fluorine, neon, and then on the next row, we've got sodium. Okay, so these are ions. So what's happened, I've written out the protons or the nucleus for each of those, and then we've got the electrons. And then for the sodium ion, that is the electron that's going to disappear. So this whole energy level will be gone, and we'll have the Na+1 ion. And then for oxygen, he's got 2 extra electrons, right? They're going to go there. So we have the oxide ion, and similarly, fluorine is going to grab 1 more electron and be F-. Okay, now here is the question. What is the difference in size? And you say, well, they all have the same number of electrons. They all have 10. And basically, they're the same distance from the nucleus. So what's the difference in each of these? And I hope you're figuring out that it is the charge of the nucleus that's pulling them in. Okay, so do you remember effective nuclear charge? And I'm going to calculate that. So you take the protons, which is, I'm going to do sodium here, 11, and then minus the shielding electrons. So these 2 electrons here are shielding those outermost electrons. So we've got 2 shielding. So we have a +1 effective nuclear charge for, +9. And then for the oxide ion, similarly, we've got 8 minus those 2 shielding. So we have a +6. And then for fluorine or fluoride, we've got 9 minus 2, which is a +7. So we have a different effective nuclear charge, and that is the charge that's doing what? Holding those valence electrons close to the nucleus. Okay, so the next thing we need to talk about is Coulomb's law. And Coulomb's law, remember, it's all about Coulomb's law when you're talking about attractions. So Coulomb's law, the force is a constant times the 2 charges, whatever the 2 charged particles are, divided by r². So in this case, distance is not a factor. So r is the distance, and so they're really, the electrons are basically the same distance from the nucleus. So throw that out. It's all about the charge, okay? And so Q1 would be the charge of an electron, and then Q2 is the other charge, which is the nucleus pulling that electron towards itself. Okay, so all that to say is this: the greater the effective nuclear charge on those valence electrons, the greater the Coulombic attraction. So who has the strongest force here? The strongest force is on the sodium's valence electrons, right? So they have the greatest Coulombic attraction. So what does that mean? They will be the smallest. That force is pulling those electrons in just a little bit tighter. And so that would be the smallest. And then the next one would be, you guessed it, would be the fluorine. Okay. And then last of all, the largest one would be the oxide. And so again, Coulomb's law is the secret here. So we're talking about identifying effective nuclear charge and then the relative distance from the nucleus. I hope that helps.